Welcome everyone. We're going to end up seeing radical equations that are more challenging. And so we follow the same procedure as before where we isolate the radical, eliminate the radical, and isolate the variable. We're going to add some extra steps though. First we're going to look at expanding x plus 3 squared. So if I have x plus 3 squared, how do I expand it? So we can do the following. X plus 3 squared is x plus 3 times the quantity x plus 3. So if I use double distributive, I have x, and what I mean by double distributive, take the first term, multiply it by the second binomial. Okay. And then take the second term, multiply it by the same binomial, which is x plus 3. So now we just distribute. X times x is x squared, x times 3 is 3x, and then 3 times x is another 3x, and 3 times 3 is 9. My like terms, and we have x squared plus 6x plus 9. This is supposed to be a 6, and here's a square, okay? So that's one way of expanding. Or you could just take first square the first term, square the second term, which is going to be your c value, and then just multiply 3 times x by 2, which is 6x. That's another way. Okay, so let's look at our first example where we are trying to solve for k. And so just like before, we want to end up isolating the radical, so we square both sides to isolate, and we have then k squared is equal to 2k. I'm going to set the equation equal to 0, so I'm going to move that 2k, since the 2k is positive, we're going to do minus 2k. So then we have k squared minus 2k equals 0. So if you notice, what is the greatest common factor between k squared and 2k? It is k. So I could have k squared divided by k is k, and then 2k divided by k is just a 2. That equals 0. So now we solve it. Remember we did the first term on the outside, k could equal 0. And the second term, k minus 2, k equals 0. If I solve for k, we would add 2. So k is equal to positive 2. So I get two solutions. It's either positive 2 or 0. I actually have to check to make sure that these solutions work. If it works, then that's our solution. If it doesn't work, that's an extraneous solution. So if I plug in here k equals 0, I'm going to end up with 0 is equal to the radical of 2 times 0. And that's just 0. 2 times 0 is 0. Radical 0 is 0. So is 0 a solution? Yes, because I get what the equation states. Let's look at the next case where k is equal to 2. So I plug in 2 for k. I have 2 times 2, but don't forget the radical is there. And then 2 times 2 is 4, so I have radical 4, and radical 4 is 2. So in this case, both of these are solutions. K equals 0 and k equals 2 are both solutions of these equations, okay? And that's okay. Now let's look for a little bit more complicated, where always remember to check for extraneous solutions by substituting back. Set up in standard form a quadratic, then factor. So we're going to go through what does that mean. So again, we isolate the radical by leaving it on one side, in this case, and then we end up eliminating the radical. So I square since I have a square root. And so now we have 72 minus x equals x squared. Now remember, we want it set up like the equation ax squared plus bx plus c. So what do? We move the 72. 72 is positive, so I'm going to do a minus 72. The x is a negative, so I'm going to do a positive x. I can't forget that it's on both sides, so I'm adding an x over here, and I'm subtracting a 72. So what do we have left? We have 0 on the left side. On the right side, it's x squared plus x minus 72. Since I have it equal to 0, I'm going to factor. Okay, so I'm looking for factors of 72 whose sum is 1. Okay, remember our ABC. A is 1, B is 1, C is 72. So I multiply A times C, whose sum is B. And that would be A times C is 72. My B value has to be 1. So factors of 72, well, the one that works is 9 and 8. Okay? So, and 9 has to be positive and 8 is negative. So I write this as x plus 9 and x minus 8. And that equals 0, right? So now we separate both binomials. X plus 9 equals 0. X minus 8 equals 0. For the first one, we subtract 9. So we get x equals negative 9. The second one, we add 8. So we get x equals positive 8. Okay. Now we have to check, is this a solution? So we're going to go back and substitute x in the first case if it's negative 9. So I'm going to use negative 9. And if I do a minus a negative 9, that turns into a positive. And then take the square root. So that actually becomes 81. On the right side we have, does it equal negative 9? Well, that right away can indicate if I take a radical of a number, it's always going to be positive. So in this case, it is not. So this x equals negative 9 is an extraneous solution. Okay. And then now let's try the 8. So if I plug in 8, 72 minus 8, does that equal 8? Well, 72 minus 8 is 64. And radical 64 is 8. So this is an actual solution. So x equals 8 is a solution, and x equals negative 9 is an extraneous solution. Okay. One more example. Right here, so we have x minus 3 on the right side. And I have a radical, so how do I undo the radical? I square it on both sides. And we're left with 2x minus 7 is equal to x minus 3. All of this goes together, okay? Minus 3 squared. And remember what we said from the one above. To make it easier, x minus 3, we square the first term, so it would be x squared. Multiply the first and second term, x times 3, which is 3x times 2, so that's 6x, so minus 6x. And then 3 squared is positive 9. Okay. Then we have to set it up into a standard form where it equals 0. So we're going to move the 2x by subtracting 2x from both sides. That's a 2x. And the 7, we're going to add the 7 to both sides. Oops, not that. That should be 7. So then we have 0 is equal to x squared minus 8x plus 16. So if we factor this out, we will find that we have x minus 4, and that's a square. Okay, because there's going to be 2. So if I solve for this, I set up x minus 4 equals 0. So I add 4 to both sides. X equals positive 4. Then we check. We plug it back in. 2 times 4 is 8. 8 minus 7. So we do 2 times 4 minus 7. Take the square root. So 8 minus 7, that's 1. So we have radical 1. Then on the other side we have 4 minus 3, which is 1, and radical 1 is 1. So that is a solution. Okay, so x equals 4 is a solution. I'm not going to complete the next problem, but just to let you guys know, it's going to be like similar to the one we did before, where we would just move the 3. So you would subtract minus 3. And then do the same procedure as the example from above. Because if you notice, it's going to look similar. Okay, and here you spread. So you have 3 problems for homework. So try them. If you have any questions, just email. Thank you.